Data imputation is one of the several important pre-processing steps for machine learning. Now let's cover another, centering and scaling our data. Let's use df.describe to check out the range of some of our future variables in the numeric music dataset. We see that the ranges vary widely. Duration underscore ms ranges from 0 to 1.62 million. Switchiness contains only decimal places, and loudness only has negative values. Many machine learning models use some form of distance to inform them. So if we have features for larger scales, they can disproportionately influence our model. For example, Canon uses distance implicitly when making predictions. For this reason, we actually want features to be on a similar scale. To achieve this, we can standardize our data. Normalize or standardize our data, often referred to as scaling and centering. There are several ways to scale our data. Given any column, we can subtract the mean and divided by the variance so that all features are centered around 0 and have a variance of 1. This is called standardization. We can also subtract the minimum and divided by the range of data. So the normalized data set has minimum 0 and maximum 1. Or we can center our data so that it ranges from -1 to +1 instead. In this video, we will perform standardization, but Scikit-Learn has few functions available for other types of scaling. To scale our features, we import standard scaler from sklearn.preprocessing. We create our features and target arrays. Before scaling, we split our data to avoid data leakage. We then initiate a standard scalar object and call its fit_transform method, passing our training features. Next, we use scalar.transform on the test features. Looking at the mean and standard deviation of these columns of both original and scale data varies the change of taken place. So we can also put a scaler in a pipeline. Here we build a pipeline object to scale our data and use a KNN model with 6 neighbors. We then split our data, fit the pipeline to our training set and predict on our test set. Computing the accuracy yield a result of 0.81. Let's compare this to using unscaled data. Here we fit a KNN model to our unscaled data and unscaled training data, print the accuracy. It is 0.53. So just by scaling our data, we improved accuracy of over 50%. let's also look at how we can use cross-validation with a pipeline. We first build our pipeline. We then specify our hyperparameters space by creating a dictionary. The keys are the pipeline steps named followed by a double underscore followed by the hyperparameter name. The corresponding value is a list or an array of the values to try for that particular hyperparameter. In this case, we are tuning n underscore neighbors in the Cannon model. Next, we split our data into training and test sets. We then perform a grid search over our parameters by initiating the grid search CV object, passing our pipeline and setting the param underscore grid argument equal to parameters. We then fit out our training data. Lastly, we can prediction using our test set. So printing grid search series best underscore square underscore. We see the score is very slightly better than our previous model performance. Print the best parameters. The optimal model has 12 neighbors. Now let's incorporate scaling into our previous supervised learning workflow. So this is the wine data. The wine data, if you see this, these are few features are there. These are the features, and quality I'm taking as the target variable. So go to the here the implementation. So the quality I'm taking as the I'm dropping the quality. I'm taking the y as the quality. Running this one. Then I scaled standard scaler and splitting neighbors. Can a neighbors update? I took pipeline. So here the pipeline. This is the pipeline, and splitting the training and testing. As I said, if I here are two things. One is scaled canon, unscaled data. This is scaled data. This is unscaled data. We will compare the both accuracy. When I ran, this is scaling. We got 6.7, but when come unscaling, unscaling we've got 0.69, 69%, 77. So slightly better than scaling is slightly better than unscaled data. That is about this session. Scaling and centering. Thank you for listening. We will connect in another session. Bye.